For item number 1, we have the instructions. For each case, determine the two variables and tell whether the relationship is positive or negative. So for the first statement, the more time is spent in studying his lessons, the higher is the grade of Nelson, the average grade of Nelson. The answer is positive since the dependent variable, which is the phrase, the higher is the average of Nelson, indicates a positive relationship due to the word the higher. For letter B, if the population of fox in a forest increases, the number of deer decreases. Since the direction of the relationship between two variables is identified by the keywords, which is decreases, this is a negative relationship because the dependent variable states that the number of deer decreases. So let's moving on to letter C. The more students enrolled in a school, the more teachers are needed. This is a positive relationship identified by the keyword more. So for letter D, as a person ages, his memory decreases. This is a negative relationship due to the word decreases. Lastly, for letter E, the more workers are hired to paint the whole school, the sooner the job is done. My answer for this item is negative since the dependent variable states the sooner the job is done. That phrase, which means there is only less time consumed in doing the job. So the keyword there is less or sooner. So that is all for item number 1.
Item number 2, determine whether the following bivariate data are correlated or not. If they are correlated, tell the direction of the association. Evaluate whether the correlation is most likely strong or weak. So for our first given, here we have the annual income of the family and the floor area of the resident's house. Since there is a correlation with the income of the family and the purchase of the said house, this would have a strong positive correlation. Next, we have age and the price of a car. Since a person's age doesn't affect the price of a car they're going to purchase, this would have a strong negative correlation. For letter C, we have the gross national product and level of technology of a country. Since the level of technology of a country is dependent on the gross national income and the gross national product of a country, this would have a strong positive correlation. Here we have age and reaction time of persons over 18 years of age. Since a person's reaction time isn't fully dependent on a person's age, this would have a strong negative correlation. And lastly, for letter E, here we have the yearly income and number of years schooling of company owners. Although a person's educational background can help them with their careers, it isn't a full guarantee. Therefore, this would have a weak positive correlation.
For question number 3, here we have a group of research students want to determine whether there is a correlation between the number of theft cases, or X, and the number of vandalism cases, or Y, incurred in their school. Data for one school year show the following. In this word problem, we will determine whether there is a correlation between the variables X and Y. Here we constructed a table with columns labeled X squared, Y squared, and XY. We then proceed to completing the table by solving for X squared, Y squared, and XY using the given values. We will then get their summations and proceed to solving for the value of R using this formula right here. Substitute the values that we obtained and are written on the table, and then we use 10 as the value of N. We then simplify the value so we get R is equals to 0.57. So this value can be identified as moderately high. Therefore, the two variables has a moderately high and positive relation to each other. For question number 4, here we have a given table of the heights of the father and his eldest son in inches. Now the question is that does the data support that height is hereditary? The answer to this question is yes, height is hereditary. According to my statistical computations, the variables have a very high strength in their correlation. We know this by solving for x squared, xy, and y squared, as well as their summations, which we then use as values for this formula right here. Then we proceed to substitute and simplify the values, giving us an answer of R is equals to 0.90, which is the value of R, indicating that there is a very high degree of correlation between the two variables. Therefore, height is hereditary, which shows that the data supports the hypothesis. That is all for question number 4. Thank you.
So good day everyone, this is Villacencio from UMS Weber, and in this performance task, I'll be answering the problem number 5, and our problem number 5 is compute and interpret R for the following given data. So our data is here. So the age of a person in years, it stands for X, which 11,320, and it has the sum of it is 155, and our weight in kilogram, which stands for our Y. If we sum up that, we will have 444. So to be able to find the R in our so to be able to interpret the R for our given data, we will use this formula. So what is this formula? So this formula is a Pearson correlation coefficient, which indicates the degree relationship between the two variables. So to be able to get to be able to use this formula, we will have to get the sum of this x squared, the sum of the y squared, and the sum of the x times y. So I have sum up that, and this is the total. The sum of the x and y is 6,189, and the sum of the x squared is 2,485, and the y squared, the sum of it is 19,976. So to be able to substitute this the formula, we will have this. So we interpret that R is equals to 0.73. So therefore, age in persons in years and the weight in kilogram is moderately high.